Now that we start the study of dynamics, I want to go over a couple of things and take this out of the way. And I call this lesson 0. We are now going to start moving from the description of motion. That's basically what we have covered until now, how things move, to why things move. Okay, so you already know for a very long time that the physical agents that will contribute to the motion or the change of motion of an object are called forces. All right, and so this chapter has everything to do with forces. So what do I want you to know about forces? First of all, I want you to remind you that they are vectors, and like any other vector, they are represented by arrows. All right, and these arrows have to point in one direction, which is the direction of the force. In each question that you are going to do, I urge you to make a little sketch of the forces acting on an object. And as much as possible, I want you to put the size of these arrows, the size of these vectors, of these forces, proportional to their magnitude. So the length of each force vector shall be proportional to its magnitude. This will help you a lot understanding what is going on. For the purpose of this syllabus, all objects are to be considered as point masses, and all forces applied to an object may be represented on a single point. You don't need to have any artistic skills. You may represent the object that is being described in each question as a single point. As you're going to see later, I usually don't do that. I try to make a little the simplest possible sketch that represents the object, but that's just my personal taste. You don't have to. So for example, I put here a situation as complicated as I could imagine. So let's say that you have a car moving to the right at constant speed against frictional forces. I just represented here all forces I could remember. So this F will be the force, the driving force of the engine. This Fg is the weight, and I'm going to represent weight as Fg, and Fg stands for force of gravity, which for the purpose of mechanics, I'm going to make as an equivalent for weight. I don't put W because, as you're going to see later, W is already taken for work and a unit for power, watt. So I'll put Fg. Every time you see Fg from now on, that means weight. Then you have these two ends. These are normal contact forces of the wheels with the road. And then you have these two forces pointing that. AR stands for air resistance and FR stands for friction. All right? Now, you don't have to draw a car. You may represent the car as a single point. All right? And instead of representing all these forces, I just combined forces. So these two normal contact forces on the wheels, I combine them to put a single normal contact force there. These two resistive forces, the air resistance and the friction, I combine them to put as just one FR. And since the car is moving at a constant speed, then the forces have to be balanced. More on that later. But to represent that's my purpose over here. I need to ensure that when I do the diagram, I put this force as big as this, and this force as big as this. See the importance of doing a good sketch? If I represent the forces with equal magnitudes and therefore equal lengths, I look at my diagram and I instinctively and viscerally understand that the motion of this object is either stopped or constant speed. All right? If I just rush things up and I put one force bigger than the other, then it may confuse me into thinking that this is accelerating. All right? It's always important that you make, as much as possible, the size of each arrow proportional to the magnitude of that vector. In this case, forces. Let's see another example. A skydiver right after jumping. Okay, so again, you don't have to draw a skydiver here with the weight and the air resistance. Just put a dot, and again, weight, Fg, and AR for the air resistance. In this case, I look over here and I know what? I know that whatever that is accelerating downwards because this force is bigger than that. All right. So again, the size of the arrows proportional to the magnitude of the vectors. Important note, good vectors representation means half of the question answered. If you have a good diagram with all the numerical information that the question is providing and associated with that good diagram, you have half of the question answered. You just look over there, and from that diagram and from the numerical information, you can retrieve all the data that you need to get to the final solution for that question.